Okay, we are back in lesson 1.1, picking up on our Galileo example. And as we left off yesterday, if you recall, we're trying to figure out what graphical model fits this data and then algebraic model. So we're looking at how to graph these ordered pairs. And I said we're going to use something called stat plot. Okay, so the first thing, and let me just kind of review here, catch up Craig and then anyone else that needs it. But if you recall, let me ask you guys, what button do I use to put my numbers in the list?
Yeah.
Okay, so I'm going to go to the stat button, which is 2 over from the alpha button. And then when I get to that first screen, I just go ahead and click into edit. And it brings me up a list of numbers. And so then what we're going to do, if it's already empty, you go ahead and start entering numbers. Otherwise, you have to delete each of those numbers out. But so in L1, we put the elapsed time in seconds. So 0 through 8 is what we have in that list. And then over in L2, you arrow over there, and we have the distance traveled is in that list. The rest of you guys all have these numbers from yesterday in your calculator still? Nice part is, unless you cleared them out for some reason, they're still there, aren't they? They should be. Okay. So now our job is we want to be able to view these on the graph, right? And as we view these on the graph, it's not a line. It's not like we can type in y equals something because we don't know the equation yet. But we want to be able to see these dots. So we're going to turn on something called stat plot. So if you will, notice right above the y equals button is stat plot, yes? So go into stat plot, which means you need to do second and y equals. You will notice all of my stat plots, you have three of them? Three of them. All of my stat plots are currently off. And that's fine. Okay, that's what I want. If you leave your stat plots on when you're not using them, they can sometimes cause interference with other issues. So you want to make sure you turn them off when you get done. But for right now, we want our stat plots on, right? So I'm going to go into just plot 1. And I'm going to hit, right now, on is flashing. So I'm going to hit enter and notice on is the one that is highlighted now. Okay, so I'm turning on my stat plot. We're trying to look at dots, so we're going to keep the type on the first one. Think about what numbers we had in our list, right? We had our x values. The top row of the chart was in L1. So this is probably already preset for you, right? I am in stat plot, and then I went into plot 1. Do I need to backtrack there?
Yeah.
So right here is when I go into second stat plot. Do you have that screen?
No. Second.
Which is right above y equals. Okay, and then I hit enter to go into plot 1. And then I want to turn that on. So you want to hit enter while you are on the on. And then so when you arrow down, on should be highlighted. The type is we want the dots. Unless you use different than L1 and L2, you want what it defaults to, which you want your X's in L1, your Y's in L2. Really, you could change the marks if you want them different instead of just like a little open circle. And you can change the color if you want. I don't even know why mine says blue. I don't even remember doing that.
So blue is the default.
Is blue the default? Okay, that's what it is then. So now we have the plot on, yes? If you go ahead and click graph, so like you can click into graph now. Okay, yeah. So notice I have some other stuff graphed, don't I? Do you have some other stuff graphed probably? Maybe. How do I get this random extra parabola off? I need to go into my y equals, and that's where I have my equation typed, right? So I'm going to clear out of there. And it was one of them from the review worksheet because I was helping someone yesterday. Now, are these all of the dots on the stat that should be showing? No, we should have like what, 9 dots showing. Why do I not see all 9 dots?
Or too far.
What did you say, Dayton?
They're too far zoomed in.
Too far zoomed in? Okay. Here's the deal. You can zoom out, although I'm not sure I'd recommend zoom out. I would recommend doing this one by hand. Meaning, go into window here, and we're going to change our own settings. X-min, how low do my X's go? Do I really need my X graph going down to -10?
No, just no.
Yeah, just 0. We don't have any negatives. So I'm going to change my X-min to 0. How high do my X values go? They go up to 8. So I'm going to leave it at 10. You can change it to 8 if you'd like. Okay. X scale I'm going to leave as 1. That just says my graph counts by ones. Y-min, how low do my Y's go? Yeah, we don't need anything negative. They go 0. Y-max, how high do my Y's go? 48. So I personally am going to put in 50. If you want to put exactly 48, that's fine. But now, once you've made those changes, hit graph again. And notice on my graph, we're looking at we can see all 9 dots. Well, realize the 9th dot is at 0, 0, and we can just vaguely see the corner of it, right? But we can see all 9 dots, and it's kind of focused on those. I don't have any other random equations going through here. Okay. Did you keep up? Are we good? Okay, no one's complaining, so we must be good. So, and we're going to have some information we're going to look at and stuff here, and I'm going to sketch a graph and everything. What shape do you see here? Okay, what kind of curve? I mean, it's definitely not a straight line, yes? Because we have to figure out what algebraic model represents this. It's definitely not like y equals mx plus b, right? I don't see a straight line. Oh, does it look like part of a parabola? Can you see the parabola there? That's probably a good guess, isn't it? And so that's the idea. We're going to write an equation for this parabola. Using these values here, we're going to write an equation for this parabola. And based on the fact that it looks like a pretty solid parabola, doesn't it? The dots aren't jumping around or anything. So let me set this aside for a moment and do some catch up on here. First thing I am going to do is off to the left, just so you have the visual in your notes, is I'm going to sketch the graph a little bit. First of all, I'm going to write down that we used stat plot. And honestly, I don't know, you may want to put some more information. You know, the fact that, our numbers were in L1 and L2, I don't know. But we used stat plot. The x-axis, we put in the values for time. So in other words, it was time in seconds, right? The y-axis, we put in the distance values. So y-axis represents distance, and that distance was in terms of inches. Now, I'm not going to go fancy and put any values here, but I'm just going to write, I'm just going to kind of show you, like, that's what you're seeing in your calculator right now, is you're seeing dots that form an, approximate parabola is what it looks like. Okay. And we are assuming it's just that, right? A parabola. We said it looks like the positive half of a parabola. So in terms of what graphical model fits this data, the graphical model that fits this data is a parabola. Now, if it had been line, we'd use the equation y equals mx plus b. Thoughts on what to use for a parabola? What's our basic form of an equation for a parabola?
X squared.
Okay, something involving x squared, yes.
Isn't this that one they use like
You're thinking square root, but that parabola would be turned sideways. Okay. Huh?
Was there any way to do that but vertical?
No, we'll just only use positive values in it, which is how we'll only have. So x squared, if we're thinking equation, we're going to say y equals x squared, right? Now, here's the deal. This parabola, it goes through 0, 0. We know that, right? So since it goes through 0, 0, it's going to be y equals some type of x squared. So we don't have to worry about plus or minus anything. Okay, we don't have to think about like x squared plus x plus a number. But we do have to consider, is this just y equals x squared? Or is it wider? Or is it skinnier? Or what is it? And so what we're going to think about for this parabola is we're going to think about the form y equals ax squared. Okay? So that's the format that we're actually going to fill in numbers though. We're going to figure out what a is. Now, let's see, which way do I want to do this? I'm using x and y, yes? Although really are these x and y up here? They're not really x and y, are they? And this is where, I don't know, I could go either way. Do we want to stick with x and y, or what do we usually call time? Time we usually call t. Distance traveled, what do we usually call that? We usually call that d. So with that in mind, just to kind of get you familiar with other formats, instead of saying y equals ax squared, I'm going to use, okay, my y values are going to be my distance values. Still a, because we're trying to figure out what kind of stretch or shrink we have here. And then instead of x, those are my time values. So d equals at squared. Now, here's what I really need to know. What is a? Thoughts on how I can find out what a is? Do we know any D and T values?
Yeah, you just plug it in for B and T, like plug one of the values in.
Yeah.
And that will be
We have 9 sets of values, right? I am content with you using any 8 of those sets. Which set of values can we not really use? We can't really use 0, 0, because that doesn't tell me what A is, right? I don't know about you guys, but I don't know. And if I recall, we should all get the same thing. I personally, how do you guys feel about 2, 3?
I like that.
Sorry, I skipped over the 1 and 0.75 because, decimals, you know.
Right.
So that means 2 is going to go in place of T. 3 is going to go in place of D. So 3 equals A times 2 squared. 3 equals 4A, because 2 squared is 4. And then if we solve for A, divide by 4. And A is, my brain says 3/4. If you are a calculator person, you're saying 0.75. Officially, does it matter which we use? Doesn't matter. My answer key, it looks like I used 0.75 in my equation. Okay, because now, okay, all you have to do is write an equation that represents this situation. So, if we're using the D equals AT squared, except what is A? The 0.75, right? So D equals 0.75 T squared. And I think if you look like in the book, they did something like that. Now, could you use X and Y? Of course. If you prefer, you could have said Y equals 0.75 X squared. That would have worked as well. Now, here's the moment of truth. Does it make sense with our dots? I have those dots on the calculator, yes? My stat plot's still turned in. It's turned on. If I go to y equals and I type in this equation, if it is truly the correct equation, what should happen?
Line up.
They'll line up. 0.75x squared, I put in y1. when I graph, mine kind of looked like it was playing connect the dots. Is that what your guys' look like?
That was so cool.
Okay. So, you kind of have a self-check built in there. Did our equation work out? Yeah, I would say our equation definitely worked out. Obviously, the numbers were designed to make it work out, but. Okay, questions on that one? Did you follow? Now, I will say, so Tuesday, right? I said I'm not 100% sure how Tuesday's going to roll until I see where we end up today. You may have a little bit of a video to finish, but then other than that, it's going to be work time, right? Do me a favor, do the best you can to help your quarantined peers that are back to figure out the calculators if they need help. Now, granted, that means you guys have to remember how to do it on Tuesday. But at least you have physically seen, my hope is that between all of you, someone can remember enough to figure it out. Okay? Help each other out there.
There's going to be a video of it too.
Huh?
I have a video posted of it.
Well, this video will be posted. And the video from yesterday, so you can always go to that portion of the video and try and figure it out that way. Okay, let's try one more like this. Example 5. Use the table from example 2 to model the growth of female prisoners with an equation. Create a graph by using the percentage of female prisoners in the prison population T years after 1980. Now, notice the information is pretty much provided here from that table we had. Okay, so this table shows the percentage of females in the prison population T years after 1980. And we're going to do the same thing we did last time because we're trying to figure out an equation for this. Okay, so we're going to figure out an equation again. Which means, what are we going to start off doing? In order to see what this graph looks like, where are we going to put these values? In our list. So that means we are putting these values. I personally am going to say put them in L1 and L2. Keep in mind, if you'd rather use L3 and L4 this time, that's fine. Okay, you don't have to keep them in the same. Just remember what you're doing. Okay, so how do we get to our list? Stat. Then I just go ahead into edit. Now, you can delete individual pieces, right? Or you can clear out a column. So if I go to the heading L1 and do clear, enter, I can clear out the column.
Don't hit delete.
Don't delete the column. Clear out the column. Or you can delete individual numbers. So my times are in L1. Whoops. Try again. So in L1, I have 0, 5, 10, 15, 20, 25. Put the numbers in L2. Type carefully. Okay. If your stat plot was not turned on, you'd need to turn it on, wouldn't you? Okay. If your stat plot was not turned on, you'd want to turn it on. However, in this case, we just used our stat plot, right? I mean, I can go back in. Do you remember how to get into stat plot and check and see? Second, and the Y equals button. And there it shows me that plot 1 is turned on. You can turn on multiple plots if you want, right? But, so now I go to graph. Okay, well, first of all, I can only see portions of 3 dots and my parabola is still there. So first of all, I'm going to go back and get rid of the parabola. To get rid of my parabola, I'm going to go to Y equals and clear my equation out, right? Now, okay, I got that extra graph out of there. I only have 3 dots. So what do I have to go change?
Window.
We have to go into window. Now this time, my X values go from 0 to 25. You can put it a little higher if you want to, or you can just leave it at 25, whatever. What about my Y values? Okay, we have to go up to 7.1. It starts at 3.9, but I'm going to leave it at 0. This is 7.1, so I'm going to say 10. And now graph. I see 6 dots, which is how many I should have, isn't it? Okay. So, what shape do you see? Kind of a line? Yeah. I mean, honestly, it's kind of designed to be a line, isn't it? Yeah. So it's more like a scatter plot. Yes. I can. Sorry, one of my iPads is making noise here, and I don't know why. There's the window. You get figured out whatever you did wrong? I'm assuming you made a mistake there. Based on the look on your face, it said you made some kind of mistake. Okay. So I'm going to go with, yeah, this is a line. Okay. Now, which means when we actually graph the line, is it going to fit exactly? No, this is what you've been doing since Algebra 1, like line of best fit. Okay. So, okay, set that aside for a moment. Like previous, I'm going to kind of sketch my graph in here just so you have the basics. My x-axis, I'm not going to call it x, I'm going to call it t. My y-axis, I'm going to call it f because that's what, they were using. And then what I'm just going to show here is that I have some dots. Okay, something like that. In fact, I think I just put one too many dots in there. Okay. Now, okay, you guys called it a line. What's the equation for a line? Yeah. And I am going to say that this is a linear graph. And we're going to use y equals mx plus b. Okay. Well, for a y equals mx plus b linear graph, in order to write this equation, we need m and b. Thoughts on m or b?
Plug in.
Huh?
Plug in the numbers.
Okay, we're going to have to plug in some numbers.
B is 3.9.
Why is b 3.9?
Because when x is 0, then y is 3.9.
Okay. Remember, b stands for the y-intercept, right? So since b stands for the y-intercept, 0, 3.9 is the y-intercept. Wouldn't it be smart to use that value as our y-intercept? Definitely. So we have b. What about m? Go back to your Algebra 1. M stands for slope. And we reviewed it in Algebra 2. Don't get me wrong, but okay. M is slope. How do we find slope?
So y2 minus y1 over x2 minus x1.
Okay. y2 minus y1 over x2 minus x1. Now, I don't know about you guys. One of the ordered pairs I want to use is 0, 3.9. That makes perfect sense to me, right? Because that is that's definitely on our line, right? That's our y-intercept. Other than that, if I look at my graph again real quick, it's not too far off of a line. Officially, you can use anything you want. You're just trying to, if you had like an outlier or something that was way off, you wouldn't want to use that one. But these are all pretty close. What I usually use is the last one, the 25 and 7.1. If you use something slightly different from me, your answer might work out slightly different, but it should be similar. Does that make sense? And that's because it's not a perfect line this time that we're fitting. So if I use the ordered pairs, 0, 3.9 and 25, 7.1. In order to do slope, y1 or y2 minus y1. So 7.1 minus 3.9 over 25 minus 0. 7.1 minus 3.9, 3.2 over 25. Don't leave it like this. 3.2 divided by 25. Don't leave a decimal within a fraction. I have it written down as 0.128. Is that exact? And it is. We already talked about the fact that b is 3.9. So what is our equation? You can either say y equals 0.128x plus 3.9, or if you want to go in terms of f and t, it's f equals 0.128t plus 3.9. Okay, I'm flexible there. You know, to me, it's not all, I don't want us to get hung up on the variables. Okay, got it? Okay. Okay, let's look at what we can time-wise from the next page. Huh? Oh, I'm sorry. Dayton wants to check it. I agree. I 100% agree. Actually, I appreciate you bringing that up because I tend to, okay, we're done. Let's move on. What does he mean check it? Let's put it in and see how close we are, right? It was 0.128x plus 3.9. How close did it work out? Not bad, huh? I mean, obviously it was never going to be perfect, right? And as I look at that, that line fits pretty well. I mean, could we possibly have the line up a little higher? Possibly. We would have had to pick a different point to use. Maybe one of those, you know, two towards the right over there. But it works for me. You guys just want to see it connect the dots there, right? Okay. On this next page, we're solving equations. Okay, we've kind of gone through the basic modeling. We're just solving equations. A and B say to solve how? Algebraically. So as we solve algebraically, it's going back and using algebraic methods. Okay, all methods you know, it's just a matter of remembering them. So as we look at A, 6x cubed plus 11x squared plus 10x. Thoughts on where to start? I like it. Let's make it equal to 0. So now, as I say make it equal to 0, is it okay if I keep the 6x cubed there and move everything else over to join it? I like my first term to be positive. And I guess I know where I'm going with this problem, which is why I know I prefer the first term to be positive. So I'm here going to have 6x cubed minus 11x squared minus 10x equals 0. And you guys know how I got that, right? The fact that we basically subtracted 10x to the other side and subtracted 11x squared to the other side. Okay. What do you notice about all three terms?
No, that's
They all have an x. Think GCF here. If we factor out an x, you factor out x, 6x cubed divided by x becomes 6x squared minus 11x minus 10 still equals 0. Okay, so we factored out x. Can we continue to factor? If it factors, what method am I using? In other words, based on the fact that x is just outside, right? That x carries down. What about 6x squared minus 11x minus 10? It's your favorite, isn't it? Product of AC. What's product of AC here? Six times negative 10, which is negative 60. I need a sum of B, which is negative 11. Okay, do the math. What multiplies to be negative 60 and adds to be negative 11? 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. I think I got all the options. Was there a working option in there?
4 and 14.
Yep. You see how I went in order, right? Trying to figure out my pair. 4 and 15. Negative 15. Because it adds to be negative 11. So do you remember what to do with this 4 and negative 15? We're going to take that middle term and split it. So I'm going to keep the 6x squared. I just carry it down. Negative 11x. I'm splitting into the 4 and the negative 15. You can say 4x minus 15x or minus 15x plus 4x. I don't care either way here. Okay, do you guys have a preference? I think I'll put, if you guys don't care, I'm going to say plus 4x. And then minus 15x. And then I carry down the minus 10. I'm going to end my parentheses, and my equation still equals 0. Okay. As I continue over here, because I'm out of room, what about that x out front? Keep the x out front. Don't lose it. That represents a solution. Okay, that's one solution here. Then I'm actually going to start a bracket because I'm going to keep this all separated. 4 terms here. 1, 2, 3, 4. How do we factor when there's 4 terms? Split it in half. GCF of 6x squared plus 4x. 6 and 4 both divide by 2, and there's an x involved. So I'm going to say GCF of 2x. Divide these both by 2x. 6x squared by 2x is 3x plus 4x divided by 2x is 2 in the parentheses. What about negative 15x minus 10? What do they both divide by? 5, and since the first one's negative, we're going to say negative 5. Negative 15x divided by negative 5 is positive 3x. Negative 10 divided by negative 5 is plus 2. In my parentheses, in my bracket, and my equation still equals 0. that x still stays out front. And do you remember how the rest of this works? Two matching parentheses. So the two matching parentheses of 3x plus 2 represents one of your parentheses. And what's the other parenthesis besides 3x plus 2? 2x minus 5. You got it? So then we have the x, the 3x plus 2, all multiplying to equal 0. What do we do? Got this time 3 things multiplying to equal 0, so we're going to, we're going to say x equals 0, 3x plus 2 equals 0, 2x minus 5 equals 0. So, do you see your solutions there? X equals 0. If it's 3x plus 2, what's that one going to give me? Yep. Subtract the 2, negative 2, divide by 3, so negative 2/3. What about 2x minus 5? Five halves. Add the 5, divide by 2. And folks, if you need to write those steps out, by all means, do it. I skipped that step because I was kind of out of the room, but by all means, write those steps out. Okay, that's one algebraic method there, folks. Reviewing factoring. That time you needed GCF. I know there was one, I'm not sure we got around to talking about in class, but in lesson P7, there was one that you could benefit from factoring GCF out and then factoring the remains. Okay, I know we're running out of time. Let's look at B real quick. B has a radical. One single radical. What's your solving technique when there's a single radical? We're going to take the radical and we're going to, what? Okay, we're going to square it after we get it by itself. So the first thing I'm going to do is subtract the 3 over. So then I have the square root of x plus 1 equals 2x minus 3. I have a square root by itself, right? How do we get rid of a square root? We square a square root. If you square the left side, you square the right side. These steps sound familiar, right? When you square a square root, you get x plus 1. What happens when you square 2x minus 3? Well, let me rephrase that. How do I square 2x minus 3? Yeah. I'm not saying you have to write that out, but I know a lot of you are probably just telling me, oh, it's 4x squared plus 9. No, you got to FOIL. Okay, so I'm going to keep this x plus 1 here on the left, and I'm going to FOIL on the right. 2x times 2x, 4x squared, minus 6x on the outsides, minus 6x on the insides, makes it minus 12x, and then plus 9. Okay, this is 1. Go ahead and make it equal to 0, which I'm going to keep positive 4x squared, so I'm going to subtract x and subtract 1. So 0 equals 4x squared minus 13x plus 8. And given that I didn't have just a couple seconds left, I would normally lead you through, okay, let's check, does it factor? And in order for it to factor, there would have to be a product of 32 and a sum of negative 13. Based on what I'm saying, you can guess that I'm going to say this does not factor. What's our backup plan when it doesn't factor? Quadratic formula, right? So I'll go ahead and finish working this out. If you want to check the end of the video later, I'll work this problem out, quadratic formula. I'll record a video for Monday that has a few graphs on it. I won't know if I'll do all 4 of these examples, but I'll do a few graphs. Any other time is working on homework in class. Please come prepared to behave appropriately and keep yourself busy, right? I want to say it's Mr. Garner, okay? Based on what he said to me yesterday. I haven't talked to Mrs. Sanders, okay? Honestly, the video will probably be up before you get in here Monday, so you can always look at it ahead of time too if you want to. But get those notes done, right? We will plan Wednesday then to check lesson 1-1 homework. Got it? Okay. Have a good weekend, guys. As I finish quadratic formula real quick here. X equals negative b. So that's going to be the negative 13, so positive 13. Plus or minus the square root of b squared. So negative 13 squared minus 4 times a is 4 times c is 8. All over 2a, so 2 times 4. If I continue, 13 plus or minus, under my square root, I'm going to have 13 squared, which is 169, minus whatever 4 times 8 is.
6%.
And I end up with 41 under my radical, all over 8. Based on the fact that 41 is not a perfect square, has no perfect squares in it, this is one way you could leave your answer. You could also break it into 2 fractions and say 13 over 8 plus square root of 41 over 8 as a possible answer. Worst comes to worst, if you needed, a decimal, you could give decimals. I have written down in my notes that the decimals are 2.43 and 0.82.
I don't use it.
Okay? So, for Monday, I will give you guys little graphs. I'll do that video through the iPad, so it won't be this type of video. Have a good weekend.